Greetings, everybody. Let's talk a little bit about the fundamental counting principle. And before I tell you what that is, I'll tell you when we use it. The fundamental counting principle is for figuring out how two events can happen in succession. Okay, so one event right after the other. Such as in my example, we go to the animal shelter, we want to adopt a dog and a cat. There's 7 cats and 9 dogs. So how many ways can we adopt a dog and a cat? So we have to do these things in succession here. There's 7 cats. We got to choose a cat. And then we have to choose a dog out of the 9 dogs. You see how it's like one thing happens and there's so many ways that can happen. And then another thing happens and there's so many ways that can happen. And we want to figure out how many ways can the combined event happen. Getting a dog, getting a cat. Okay. All right. So that's essentially when we use it. Let's talk about how it works out. So the way we normally state the fundamental counting principle in general terms is that we say if event A can happen in X ways and event B can happen in Y ways, then the event where A happens and then B happens, such as choose a cat and then choose a dog, can happen in X times Y ways. X times Y ways. Okay, so all right, let's use that to answer this question. We're going to go to the animal shelter. We're going to adopt a dog and a cat. 7 cats, 9 dogs. And how many ways can we adopt a dog and a cat? Okay, so do you see this is exactly like in my principle? Okay, we're going to choose a cat and then choose a dog. That's how it's going to work out. All right. So we could say like this, how many ways can I choose a cat? I can do that in 7 ways. And then how many ways can I choose a dog? I can do that in 9 ways. Okay. And if I multiply them, that's how many ways I can choose a dog and then choose a cat. Okay. Individually, they can happen in 7 and 9 ways, but choosing one and then choosing another, that can happen. You know, getting an individual dog and cat at your house is going to be 63 ways. Okay. All right. So there's 63 different ways that we can come home with a dog and a cat. All right. If there's 7 cats and 9 dogs. All right. Now I want to use this to a bigger problem. This will generalize to more than 2 events. Like, what if we were going to adopt a dog and a cat and then a reptile or something? I don't know if they have reptiles at animal shelters, but we could just do X times Y times Z, all right? For however many ways, any one event can happen. If you want to figure out how many ways can A and then B and then C and then D can happen, you just multiply the individual ways. Okay, so we'll generalize this if there's more than 2 events. So that brings me to this question. This one's from my math lab. Okay, let's explore this one next. So it says this. So this one is about passwords and passcodes, and maybe you've noticed as you've had to make passwords over the years, make passcodes over the years. They keep having to get longer and longer and have special symbols and so on. And it's all because it means that there's more passwords to choose from, and I suppose harder for it to hack or to be hacked because there's more of them. Okay, so this one is kind of like that. It says realtor uses a lockbox to store keys to a house that's for sale. So you punch in a code and it opens up and you get the key to the house and you go in. All right, and you show people the house. The access code for the lockbox consists of 6 digits. Now, just as a way to think about that, I wrote these 6 lines right here like that. So I'm envisioning those as like the 6 digits of the code to the lockbox. Now, there's some specifications that I don't entirely understand, but this is what they give us. It says the first digit can't be a 5. I don't know why that is, but that's what it says. Okay, and it says the last digit must be even. Again, I don't know why that is, but that's what it says. That's what we got to work with. All right. Okay. So let's see. Now, if I was going to create an access code like this, I would have to choose a number for each spot in the code. Like I'd have to choose what the first digit was, and then choose what the second digit was, and then choose the third digit. You see, like I'd have to do these things in succession, all right? So to figure out how many total ways I could choose what that passcode is going to be would be just a matter of multiplying, how many ways can you choose every individual digit? Okay, that's the way the counting principle works. It's the same idea as that example I gave where we go adopt a dog and a cat. How many ways can you adopt a dog, and times how many ways can you adopt a cat? So let's figure out like this. I'm going to put how many ways I can choose each digit in here. And I'm not saying the first digit is 9. When I put a 9 like that, I'm saying there's 9 choices for the first digit. Why is that? Well, I've got 10 digits to work with on the keypad. Here they are. And it says the first digit can't be 5. Well, that means there's 9 digits to choose from. Okay? So, all right, I got 9 digits to choose from for the first number. But then I have 10 on the second because it says there was no restrictions. I could choose any of the digits 0 through 9 on the keypad as the next one. And then 10 for the third, and then 10 for the fourth, and then 10 for the fifth. But then when I get to that last digit, it said that that last digit must be even. And then for clarification, 0 is going to be considered an even number. So let's see. For that last digit, like I could choose 0, 2, 4, 6, or 8. Those are the even numbers, all right? So let's see, that's 1, 2, 3, 4, 5. I got 5 choices for that last digit. All right, now the total number of possibilities for a passcode created by these specifications is going to be 9 times 10 times 10 times 10 times 10 times 5. All right, so let's see what that is. 9 times 10 times 10 times 10 times 10 times 5, that's like 450,000. Let's see. So yes, 450,000. I just multiplied it all together. And so that would be our answer. All right, there are 450,000 possible codes that you could make. So if somebody was going to go up to the door to break in and just try to randomly guess codes, they'd have like a 1 out of 450,000 chance on any one guess of getting it right. Okay, can you imagine guessing that? The lottery is kind of like this, a little bit like this, where it's like, there's so many digits that you have to choose correctly to get a correct choice or match on the lottery, but then there's like 50 something, 60, I don't know, choices for each one of those numbers. So the options are staggering in terms of the lottery, and that's why it's not real likely that anybody wins on any one ticket.